Hello and welcome to my YouTube video on Traveling Salesman Problem using genetic algorithm. My name is Vinaya Sri and I am currently pursuing my third year of Bachelor of Technology in Electronics and Communication Engineering. For my course project, I have implemented the Traveling Salesman Problem using genetic algorithm. In this video, I'll be demonstrating how genetic algorithm can be used to solve the traveling salesman problem. I will explain the algorithm, show how it works, and discuss the results of the implementation. I hope you find this video informative and useful. Let's get started. The objective of my course project is to implement a genetic algorithm to solve the traveling salesman problem. This involves the understanding the concepts of traveling salesman problem and genetic algorithm, as well as learning how to apply genetic algorithm to solve optimization problems like TSP. TSP involves finding the shortest route that visits a set of cities and returns to the starting city. However, the time complexity of solving TSP using brute force is exponential, which makes it computationally expensive for larger problem sizes. Genetic algorithms have been shown to be a powerful technique for finding near optimal solutions of TSP, which is with a much lower time complexity of big O of n scale. Now let's see the algorithm. Genetic algorithms solve complex problems by generating a population of potential solutions and iteratively refining this population using genetic operators. This mimics the process of natural selection and genetic inheritance in biological organisms. The fittest individuals are selected to form the next generation, resulting in increasingly fit individuals over time. This approach has been to be a powerful optimization technique across the wide range of fields. Now let's see the flowchart of how genetic algorithm works. Genetic algorithm follow a specific flowchart in order to solve optimization problems. The algorithm begins by initializing the population, which are evaluated using fitness function. The fittest individuals are then selected to form the next generation, which undergoes crossover and mutation to introduce the new genetic material and diversity into population. The new generation replaces the old generation and the process repeats until a stopping criterion is met, such as maximum number of generations or a satisfactory fitness level. The best individual in the final generation is then selected as the solution to the problem. Following this flowchart, genetic algorithms are able to converge towards near optimal solutions to complex problems. There are many applications of genetic algorithm. Among these 10 applications, I have chosen traveling salesman problem. Now let's see how traveling salesman problem can be solved using genetic algorithm. The problem statement of traveling salesman problem is that a salesman is given a set of cities and he has to find the shortest route to visit each city exactly once and return to the starting city. The approach of this problem is that the implementation of TSP using genetic algorithms involves generating a chromosome using the set of cities which are represented as genes. The algorithm then calculates the fitness score for each chromosome by computing the length of the path described by the genes. Shorter paths are considered for the fitter genes, and the algorithm selects the fittest gene to survive and form the next generation. This process continues until the algorithm reaches the stopping criteria, which is determined by Cooling variable that decreases with each iteration. The number of iterations depend on this variable and reaches threshold after a certain number of iterations. By using genetic algorithms in this way, we can find the shortest path among a set of cities efficiently and effectively. This is the algorithm of the code which I have followed, which is clearly explained in the flowchart part 2. Now let's check the code. I have created a class named genetic to define all the methods of the genetic algorithm. Initially, the init method is the construction method of genetic class. It initializes the population list, population size, fitness list, and other important variables like current distance, current fitness, first index, and mutation. And it is followed by the calculate fitness. This method calculates the fitness score for each chromosome in the population. It takes a list of points, coordinates of the cities as input, and calculates the total distance traveled by each chromosome. The fitness score is calculated as 1 by distance, where distance is the total distance traveled. The method also updates the record and fittest based on the fitness scores. The method normalizes the fitness score of all chromosomes in the population. It calculates the sum of all fitness scores and divides each fitness score by the sum. The mutate method randomly mutates the genes which are known as city order of a chromosome with a given probability mutation rate. It selects two random indices and swap the values of genes at those indices. The method crossover performs crossover between two chromosomes, which are given as inputs, gene 1 and gene 2. It randomly selects start and end index of one of the chromosomes and takes a slice of the genes between those indices. It then adds the remaining genes from the second chromosome to slice in it and order they appear. The resulting chromosome is written here. In natural selection, this method performs natural selection on the population. It selects two parent chromosomes based on their fitness scores and generate a child chromosome by performing crossover and mutation. The child chromosome is added to the next population. This process is repeated for all chromosomes in the population, and the next population becomes the current population at the end of each generation. This is all about the genetic class. In the main function, the set of cities were given as the input and next followed by initializing the genetic algorithm with a population of randomly ordered list of city indices and a specified population size and mutation rates. And then followed by we have iterated through the specific number of generations performing these steps at each generation. Here, the step 1 is calculating the fitness of the current population by computing total distance traveled by each ordered list of cities and storing the reciprocal of distance as a fitness score for each test. And next, performing the natural selection to generate the next population by selecting two lists of cities from current population based on their fitness scores, crossing them over to create a new list of cities and applying mutations to the new list, which is followed by printing the shortest distance found so far and the corresponding path. We have finally printed the best path found by the algorithm, generates a scatter plot of the cities, which the best path highlighted by connecting the cities in the order. You can see that graph here. And now let's get back into the present which output which we have seen till now. This is the required graph, scatter plot graph. Now let's check the limitations. Although genetic algorithms are an effective tool for solving traveling salesman problem, they may not always find global optimum solution, particularly for larger problem sizes. Additionally, implementing genetic algorithm for TSP can be computationally intensive, especially for larger populations and problem sizes. Moreover, the quality of the solutions obtained by genetic algorithm may not be easily verifiable, as there can be multiple solutions with similar fitness values. Finally, genetic algorithm is not guaranteed to find the optimal solution with a specific time frame, which can be a drawback in real-world applications where timer is a critical factor. These limitations should be kept in mind when using genetic algorithm for TSP and other optimization problems. Let's check few solutions for these limitations. There are several solutions to the limitations of GA in TSP. Advanced GA techniques like hybrid algorithms can improve the performance of GA and increase the likelihood of finding the global optimal solution. Conducting a grid search or using other optimization technique methods to select optimal parameter for the genetic algorithm can also help. Using a combination of multiple runs of genetic algorithm along with post-optimization techniques can improve the quality of solutions obtained by genetic algorithm. Exploring other optimization techniques like simulated annealing or ant colony optimization can be provided alternative solutions for solving the TSP. Adopting these solutions can improve the effectiveness and efficiency of genetic algorithm in solving TSP and other optimization problems. Hereby, I would like to conclude that the implementation of genetic algorithm for TSP is a promising approach that can help to solve this challenging optimization problem. By exploring the potential solutions to the limitations of GA, we can further improve the performance of this algorithm and apply it to solve other optimization problems in the future. References. These are the references that help me to develop a better understanding of the theory and practical implementation of TSP using GA. I encourage you to explore these resources further if you are interested in learning more. Thank you.